Hi there. For this video, we'll be discussing some examples on nested absolute value equations. So when we say nested absolute value, we'll have these types of absolute value, wherein we have here absolute value of the absolute value of x plus 1, like that. So it might seem scary at first, but you will see that it is just simple. But before we can solve those types of examples, let us first recall the three basic cases in absolute value equations, since we will be needing this in answering nested absolute value equations. So recall that if we have the absolute value of x and this one is equal to y, we either have y to be less than 0 or negative, y to be equals 0, or y to be greater than 0. So that is positive. When we have y is less than 0 or negative, the answer here is no solution, since we can't have a negative output from the absolute value. If y is equal to 0, then we know that x must be equal to 0. And if y is greater than 0, then we'll have two cases. We either have x equals y or x equals negative y. So we'll be needing these concepts in our answer or in our solution to these examples. So let's start with our first example. Let's have the absolute value of x plus 1 minus 1 equals 1. So let's first fix the 1, since there are a lot of vertical lines out here. So let's write here 1, like this, and like this, there. So how do we solve this? The key is to treat the absolute value from the outermost to the innermost. So we can treat this whole out here to be simply just a, and then we can apply the basic cases that we had in the first series of these absolute value equations videos. So if we treat this as one variable, and this one on the right is positive for greater than 0, then we know that we'll have two cases. So we have here case 1 and here case 2. So for case 1, we have the absolute value of x plus 1 minus 1 is equal to 1. And for the case 2, we have the absolute value of x plus 1 there minus 1 equals negative 1. And then we solve these cases out here. For the first case, we first move this to the right side to obtain x plus 1 is equal to 1 plus 1 is 2. And for the case 2, moving this negative 1 out here, we'll have x plus 1 to be equal to 1 minus 1 will have 0 out here. And now we have another series of absolute values. For this first case, note that since this is positive, we'll have another two cases. So we'll write that one as case 1.1 there, and case 1.2. So again, if it is positive, we either have x plus 1 equals 2 or x plus 1 equals negative 2. For the case 2, or this one out here, since the right side of the equation is 0, then we know that the only case for this one is this expression inside being 0. So we'll have here x plus 1 equals 0. And then we solve these linear equations. So for this case 1.1, we simply move this to obtain x equals 2 minus 1 will be 1. Then for the second case, or the case 1.2 rather, we move this out here to obtain x equals negative 3. And then for the third case, or the case 2, sorry for the confusion for the numbering of cases, but for this case 2, we simply move this 1 out here to obtain x equals negative 1. So we have 3 values. What we need to do next is to check if these values satisfy our original equation. So let's list these out. So we've got x equals 1, x equals negative 1, and x equals negative 3. Yep. So let's remove this one out here. And let's start verifying. So we are gonna start with x equals 1. So for x equals 1, we'll have the absolute value of the absolute value of 1 plus 1 plus minus 1 rather. And there. First, we simplify this one out here to obtain the absolute value of the absolute value of 2 minus 1. This is simply the absolute value of 2 minus 1, or simply the absolute value of 1, or simply 1. So it satisfies our equation out here. So we say that x equals 1 is a solution. Next, let's have x equals negative 1. At x equals negative 1, we'll have the absolute value of negative 1 plus 1 minus 1 there. Then this is equal to the absolute value of 0 minus 1, or simply absolute value of negative 1, since 0 here is just 0, don't need that. Then getting the absolute value of negative 1, this is simply 1. So negative 1 is also a valid solution. Third one, or the last one, at x equals negative 3. We have the absolute value out here of negative 3 plus 1 minus 1, and there. So simplifying this, we'll have the inner absolute value will be negative 2 minus 1. The absolute value of negative 2 is simply 2 minus 1, simply absolute value of 1, or simply 1. So negative 3 is also a valid solution. And so we conclude that all the 3 values of x that we got are solutions to this absolute value equation. So pretty simple. That is just how we get or solve for the value of x in nested absolute value equations. Just a lot of cases, but it's very straightforward. Let's try this second example. Let's have the absolute value of y minus 2 minus 2 equals 6. So again, since 6 is a positive value, we'll have 2 cases. So we've got case 1 out here and case 2 out here. For case 1, we've got the absolute value of y minus 2 equals 6. And for case 2, we've got y minus 2 out here equals negative 6. So let me start with the case 2, since this one is interesting. So observe that if we move this to the right side, we'll obtain y minus 2 is is equal to negative 6 plus 2 is negative 4. And what can you observe? Observe that negative 4 here is less than 0 since it's negative. And remember that when we have this case, y has no solution. So for case 2, we don't really need to do anything anymore since that case is invalid. Since again, we can't have a negative output from an absolute value. So, no need for case 2. And we simply have this first case. So for this one, simply move this to the right side to obtain the absolute value of y minus 2 equals 2 plus 6 is 8. And then from here, since now we have a positive value, unfortunately, we'll have 2 more cases for this one. So we've got case 1.1 and case 1.2. For case 1.1, we've got y minus 2 equals 8, and for case 1.2, we've got 1 minus 2 equals negative 8. Simplifying these linear equations, simply move negative 2 to the right side. We obtain y equals sorry for that. We obtain y equals 10, and out here we obtain y equals negative 8 plus 2 is negative 6. There. Last step is to verify these values. So observe that if we plug in y equals 10, we'll have the absolute value of 10 minus 2 out here. This one out here will be equal to 8. So we've got the absolute value of 8 minus 2, or simply absolute value of 8 minus 2, or absolute value of 6, or simply 6. So it matches our value in our original equation. So y equals 10 is a solution to this. For y equals negative 6, we've got the absolute value of negative 6 minus 2 out here. This one is equal to the absolute value of this one out here is negative 8. So the absolute value of negative 8 is simply 8 minus 2, or absolute value of 6, or 6. So matches the original equation as well. Therefore, we have found 2 solutions for this problem. We have either y equals 10 or y equals negative 6. And so that is how we solve nested absolute value equations. Seems scary at first, but as long as you know the basic concepts in absolute values, you can easily solve these types of examples. Before I end this, here's an exercise that you can work on to test your skills in nested absolute value equations. So we have here the absolute value of 3 minus 4 times the absolute value of z plus 1, and this one is equal to 2 minus z. So might seem scary at first because we have an expression out here. But note that you can solve this by the cases strategy as well. So if you still don't know how to deal with having an expression on the right side of the equation, you may check out the second video in this absolute value series equations. since in that video I tried to tackle absolute value equations examples wherein the right side of the equation is an algebraic expression. So that's it. I hope you enjoyed this video. Feel free to comment down below your answers and solutions to this exercise, and if you tried the examples, please share your solution as well. So that's it. I hope you enjoyed this one, and that is all for this video.